আজকে একটু ব্যাটারি ইস্যু আছে, জানি না পুরোটা রেকর্ড হবে কিনা, চেষ্টা করছি। ওকে, সো লেটস স্টার্ট। আই হোপ দ্য স্ক্রিন ইজ ভিজিবল। স্ক্রিন তো দেখা যাচ্ছে, সবাই দেখতে পাচ্ছো?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
কোয়েশ্চেনটা ছিল লাস্ট দিন, দ্যাট ইজ দ্য কোয়েশ্চেন ওয়াজ why is paranitrophenol more acidic than phenol? তো এটার আনসার কেউ ট্রাই করোনি? ধ্রুব?
স্যার ওটা লিখতে পারছিলাম না, খালি ওটা মনে আছে যে NO2 মাইনাস গ্রুপটা।
হ্যাঁ,
স্যার
ওখানে
NO2 মাইনাস গ্রুপ থাকার,
বলো
স্যার ওই
বলো।
যে অ্যাসিডের মানে ক্যারেক্টারটা ইনক্রিজ করে দিবে।
অ্যাসিডিক ক্যারেক্টারটা ইনক্রিজ করে দেবে। কেন ইনক্রিজ করে দেবে বলো বলো।
অ্যাসিডিক ক্যারেক্টার কেন ইনক্রিজ করবে?
হ্যাঁ, কেন ইনক্রিজ করবে বলো। দেখো, ভালো করে লক্ষ্য করো একটা জিনিস। দিস ইজ প্যারানাইট্রোফেনল। ধ্রুব, করেছো এটা?
নো স্যার।
কেন করোনি কেন?
না সেটা পারি নাই।
আচ্ছা, যাই হোক, দেখো, নাইট্রো গ্রুপ contains an effect. What kind of effect? This is minus R or minus M effect, right? So due to this minus R or minus M effect, the nitro group drags the electron density from the benzene ring towards itself, right?
হ্যাঁ স্যার।
So this is the resonance. Now this electron density from OH group goes inside the benzene to neutralize this positive charge. Just show it like this. Okay,
হ্যাঁ স্যার।
so we can say that the polarity of the OH bond is more compared to phenol due to the presence of minus R or minus M containing nitro group. So the polarity of the OH group, is more due to the presence of minus R minus M effect containing NO2 group. Because that's it, nothing else. Okay, understood everyone?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
Okay, so let's start the new chapter today, that is hydrocarbons, a very important chapter, or one of the very important chapters in your class 11th chemistry. Okay, first of all, what do you mean by hydrocarbon? This is chapter number. Chapter number what? I guess this is chapter number 13, right?
Yes, sir.
From your NCRT part 2. Okay, so let's start hydrocarbon. What do you mean by this term hydrocarbon? See, the word hydrocarbon contains two
Hydrogen and
parts.
carbon.
One is hydro, another one is carbon. So those compounds of organic chemistry are called hydrocarbons, which contain carbon and hydrogen as a primary element. Right. So hydrocarbon contains carbon and hydrogen. Okay. Carbon and hydrogen. All right. So what are the uses of carbon? Hydrocarbon. Hydrocarbon is everywhere. You see in the uh, petrol, diesel, kerosene, okay, even LPG, okay, these all are basically hydrocarbons, right? So everywhere there are hydrocarbons. In polythene, there is hydrocarbon, okay. So it's a very, very important compound. So first of all, what are the classifications of hydrocarbon? As we have discussed in the last chapter, the hydrocarbons mainly of two types. Okay, hydrocarbon mainly of two types. Just a moment. Okay, hydrocarbons are of two types. First of all, saturated. Secondly, unsaturated. Okay, what do you mean by saturated? If the hydrocarbon contains only single bond, only single bond, we'll call it a saturated hydrocarbon. On the other hand, if the hydrocarbon contains either of the double bond or triple bond, either double or triple bond, we'll call them unsaturated hydrocarbon. Okay, all right. Now this saturated hydrocarbons containing only single bonds are also known as alkanes. Right. On the other hand, the unsaturated hydrocarbons are known as, basically they are of two types. Let's divide
Alkene
them
and
into
alkyne.
two more categories. That is
Alkene and
alkenes
alkyne.
and alkynes. So what are the alkenes? They contain,
Double bonds.
yes, very good, double bond. And what is alkynes? They contain
Triple bond.
Triple.
triple bond. Okay. Some examples. Let's say an example of alkane is methane. Methane. An example of alkene is ethene, C2H4, right? An example of alkyne is ethyne, formula C2H2. Okay, C2H2. So now our main goal is to discuss all these three hydrocarbons, like one by one, alkane, then alkene, then alkyne. Okay, one by one we will discuss all these hydrocarbons. Fine. So first let's discuss alkanes. So as we have discussed earlier that alkanes are what? Alkanes are saturated hydrocarbons. Saturated hydrocarbons. Hydrocarbons. So they contain only single bond. There is no issue with that. right? So the family of hydrocarbons are called the homologous series. Now, in the last chapter, we have already discussed regarding the homologous series. So, we will have to discuss the homologous series of alkane, alkene, and alkyne in this chapter. So, what do you mean by homologous series? Can anyone tell me? के बोलबे बोलो?
Sir, sir,
हाँ, बोलो.
successive compounds differ by CH2 group.
Yes, very good. Successive compound differ by a CH2 unit or a molecular mass of 14 unit
14 U.
or 14U. So in a series in which the successive members differ by CH2 group. See how I have written this CH2? You will have to write it like this, okay? CH2 group or 14U, that is atomic mass unit, okay? In general, the formula of alkanes are CnH2n plus 2. This is the general formula of alkane. Okay. Now we'll write down the homologous series of alkane along with the structure. I'm not going to draw all these structures. I'm going to draw a few structures of alkane. So let's see. See the homologous series of alkane. First of all, formula. Okay. Secondly, name, and then structure. So one by one we are going to discuss. So the first member of this alkane family is CH4, and you know what is the name of this compound, I guess. The name is obviously methane, and the structure of methane is something like this. Actually this is not the structure, but still we draw it like this. Actual structure is tetrahedral, okay? Secondly, number 2, just add a CH2 with this methane, that is C2H6. The name of this compound is ethane. Here also you just add a CH2 unit with this methane. Simply add a CH2 unit with methane. Everything else will remain as it is. Understood, everyone? Have I added a CH2 with this? Yes or no?
Sir.
Okay. Number 3, propane, that is C3H8. Just adding another CH2 with ethane. So the name is propane. Similarly, you just take the structure of ethane, simply add another CH2 with that. So what is the structure? So this is the structure. So there will be one more CH2, right? One and another one. So two CH2 units will be there. Are you understanding what I am doing?
Sir.
Everyone,
Yes, sir.
I am just adding a CH2 unit, nothing else. So will you be able to complete this till number 10, that is decane?
Sir.
Number 10 is decane. Okay. The structure of decane, who will say? C10H.
C5H2N
Decane.
or Decan.
C10
Oh, C10H
H22. 22.
22.
22, exactly. C10H22, that is taken. तो एक एक करके CH2 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 ऐड करते 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 जाना है, ठीक है। बहुत ही इजी है, कोई खास दिमाग लगाने की जरूरत है नहीं इसमें, समझे क्षितिज?
हाँ सर।
हो जाएगा, छोड़ दे यहाँ पे इसको। क्षितिज
हाँ सर,
छोड़ दे इसको यहाँ पे, बाकी कर लोगे 10 तक, डेकेन तक।
कर लेंगे। हाँ
ওকে,
सर।
বাকিটা সবাই বুঝতে পেরেছো? শাগনিক,
হ্যাঁ স্যার বুঝেছি।
আচ্ছা কে বলো ডেকেন অবধি করতে পারবে তো? সবাইকে জিজ্ঞেস করো। সৌম্যদীপ,
হ্যাঁ স্যার।
অসুবিধা নেই কোনো?
না স্যার, বুঝে
ওকে,
গেছি।
now we'll have to discuss the structure of alkane, but we have already discussed it in the chemical bonding chapter, but again we need to discuss the structure of alkane, the molecular structure of alkane. Okay, structure of alkane, especially the structure of methane that we have to discuss. So obviously we know the central carbon atom in methane is sp3 hybridized. So these are the lobes of sp3 hybridized methane, sorry, hybridized carbon, right? And there are 4 hydrogens, 4 spherical s orbitals of hydrogen attached like this. All right, so basically this is the structure of methane. Okay, understood? So this is basically the structure of methane. What is the hybridization of carbon? Everyone, the hybridization of carbon is sp3. What is the bond angle? 109.
109.5 degree.
Okay, and the hybridization is sp3. Okay, so nomenclature we have already done. You know about the nomenclature of alkane, so just have a quick revision. Nomenclature of alkane, this we have just done in the last chapter. We have done so many types of nomenclatures there, so just tell me the name of this. You people will do this. CH3, CH, CH3, CH, CH3, CH2, CH2, CH3. বলে ফেলো নাম কি হবে এটার? Yes, who will say?
স্যার,
হুম,
স্যার বলবো?
বলো।
স্যার 2,3 ডাইমিথাইল হেক্সেন।
2,3 dimethyl hexane. Very good. 1, 2, 3, 4, 5, 6. So in the main chain there are 6 carbon atoms containing no double bond, no triple bond. So obviously it's an alkane. And in the second and third carbon there are 2 methyl groups. So that's why 2,3 dimethyl hexane. Hexane, why? Because there are 6 carbon atoms. So if there is one carbon atom, we'll call meth. 2 carbon atoms, there are it is eth. C3 prop, C4 bute, C5 pent, C6 hex, C7 hept, C8 oct, C9 non, C10 dec. If they are alkane, just put a ANE after each of them. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, like this. If there are alkene, put a ENE. After meth, eth, probute, pent, hex, hept, oct. Methene. Methene obviously cannot be possible, so it will start from C2, that is ethene, propene, butene. Okay. Similarly, it is alkyne, so obviously thine, propine, butine, pentine. So remember these prefix. Okay. So this is the name. Okay. Now what about the isomerism? Tell me the types of isomerism that is present. Yes,
Sir, structural and stereoisomerism.
stereoisomerism. No, stereoisomerism is not there.
মানে অ্যালকেনের
Yes,
ও
alkane. You know, you have already,
ও চেইন আইসোমেরিজম এন্ড পজিশন আইসোমেরিজম
yes, the chain and the positional isomerism are the two types of isomerism. Okay, for example, if you take this one, that is butane, CH3, CH2, CH2, CH3, this is butane. Okay, this is also butane. See, they both have C4 and H10, right? C4, H10, just have a count for both these two. Is it C4H10? How many carbons are there? 4 carbons
হ্যাঁ
are
স্যার
there in each of the cases. And how many hydrogens are there? 3, 2, 2, 3. Obviously 10. Similarly here also 3, 3, 3, 9, and 1, 10. So for both of them, C4H10. So these are what type of isomerism? Chain isomerism. So we'll call it, the first one we'll call it N-butane. And the second one is isobutane. Alright. So this is basically the isomerism in alkanes. Similarly, in case of pentane, also you have isomerism. For example, this is what Shobik bolo. This one, and this one. Shobik, tell me the names.
হ্যাঁ স্যার
Huh. বলো ভালো।
স্যার প্রথমেরটা এন পেন্টেন
N-pentane. Second one, obviously iso.
আইসোপেন্টেন
And the third one is
নিওপেন্টেন
neopentane. So these are the isomers of pentane. N-pentane, isopentane, neopentane. Okay. Understood?
হ্যাঁ স্যার
হ্যাঁ স্যার
So these are the examples of chain isomers, right? Chain isomers. So they differ by the alkyl
CH
chain, right? Alkyl chain. So can you give me an example of positional isomerism? Can you give me an example of positional isomerism? It's a very simple example. What is this? What is the name of this compound? Yes, who will say? Very simple.
স্যার আইসোহেক্সেন
Isohexane. Simply tell me the
ও তাহলে
IUPAC
হ্যাঁ
name.
ও ঠিক আছে 2 কমা 2 কমা
2 comma
না 2 মিথাইল 2-methyl pentane.
Pentane. Very good. 2-methyl pentane. What is the name of this? What is the name of this?
3-methyl pentane.
3-methyl pentane. What type of isomerism is shown by them?
Positional.
Positional. Okay. Okay. Now in NCRT, you will get a lot of example of IUPAC nomenclature. Along with that, you will also get the example of, yes, the nomenclatures are there. Along with that, some questions are also there. Okay. We'll be discussing about the questions later in this chapter. Okay. Now, without wasting any time, we'll directly move towards the preparations of alkanes. Okay, preparations of alkanes. I'm not focusing too much on the nomenclature because we have already done this in the last chapter. So that's why I expect you people to practice these nomenclature from the books. Just write down the structures and try to do the nomenclature by yourself. Okay, and if you feel any doubt, any query, then ask me. Okay, anytime you can ask me. You can text me in the WhatsApp, or you can just call me simply. Okay, whatever you want. If you face any doubt, any difficulty in doing nomenclature, okay, after practice, okay, obviously if you do not practice the nomenclature, then you will certainly face problems. But if you practice, then I'm sure you will not face any kind of problems while doing the nomenclature. Okay, so let's continue the preparation of alkanes. So there are many ways by which we can prepare alkane. So the first and the most important way is that preparation from alkene and alkynes. How can we prepare alkanes from alkenes and alkynes? Okay, the process is called hydrogenation. The process is called hydrogenation. Okay, see, CH3, CH double bond, CH2. This is called propene. What? This is called propene. Why propene? Because it is basically an alkene. We will discuss when we'll discuss alkene. We'll discuss about it also. But as of now, because it's just the preparation, so that's why we have to deal with this. So this is alkene and 3 carbon containing alkene. So that's why the name is propene. So you take propene and you simply treat propene with hydrogen, and along with hydrogen you take nickel or platinum or palladium, okay, as a catalyst. Okay, so what will happen? The hydrogens will be added up. The hydrogens will be added up like this. Okay, this is called hydrogenation. You can also call it reduction. Have you understood why I am calling it a reduction? सलोनी, इसको रिडक्शन क्यों बोलते हैं? सलोनी बोलो, इसको रिडक्शन क्यों बोलते हैं? Why am I calling it reduction? কে বলবে?
স্যার হাইড্রোজেন অ্যাড করা হচ্ছে তাই।
Yes, hydrogen has been added. So that's why I am calling it reduction. It's quite simple. Okay, if hydrogen is added, this is reduction. If hydrogen is removed, that is oxidation. So that's why you can also call it reduction. Similarly, if you have an alkyne,
স্যার অক্সিজেন
হ্যাঁ বলো 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 বলো
স্যার
কি বলছো?
অক্সিজেন রিমুভ করা যাবে না?
অক্সিজেন আছে কোথায় যে আমি রিমুভ করব?
না স্যার, তখন তো রিডাকশন হবে না?
হ্যাঁ, obviously হবে. That is also a type of definition of reduction. If you remove oxygen, that is reduction. If you add hydrogen, that is also reduction. So here what is happening? Addition of hydrogen is happening. যদি আমরা অক্সিজেনকে রিমুভ করতাম তখন আমি তাকে রিডাকশনই বলতাম, তাই তো?
হুম।
CH3C, triple bond C, single bond CH3. The name of this compound is what? Butene. Just write butene, okay? Butene. So obviously there is a triple bond. So we can apply hydrogen and nickel here as well. But we have to apply a double amount of hydrogen here. Okay, 2H2. Okay, so what is the result? The result is quite obvious. There will be no unsaturation, only single bond, and the hydrogens will be added up like this. The H2 at the bottom and another H2 will be above the two carbons of triple bond. Okay, now there is no unsaturation. This has been converted into an alkane. So by this reaction, you can convert an alkene or an alkyne into an alkane quite easily. Okay, understood? So this was the first reaction or the first reaction to prepare alkane, okay, from alkynes and alkenes. The second one, that is process number 2, from alkyl halides. From alkyl halides, see, how can we prepare alkane from alkyl halides? This is methyl chloride, right? You simply do hydrogenation of methyl chloride, but alongside an acid and keep zinc metal. Okay, any type of acid like HCl. HCl is in general used. Okay, HCl, and along with that we use zinc. So zinc in HCl. Okay, so what happens? This chlorine that you watch in methyl chloride, okay, this is methyl chloride, or we also call it chloromethane. What happens? This chlorine gets replaced by the hydrogen. So as a result, we get CH4, and alongside that HCl is formed. Understood? Similarly, if there is ethyl chloride, ethane will be formed. If there is propyl chloride or chloropropane, propane will be formed. Understood everyone?
স্যার মানে একটা H তোমার CH3 তে গেল আর একটা H হলো HCl ফর্ম করলো।
HCl, huh? Like
ঠিক
this.
আছে।
H. Understood?
হ্যাঁ স্যার।
You can show it like this. Understood?
হ্যাঁ স্যার বোঝা
হ্যাঁ
গেছে।
স্যার।
You don't show it like this in your exam paper. It will be difficult for the examiner to understand, but you can do it as a rough work. Okay. So as in general, just take an RCl, put hydrogen and an acid and zinc. So what will happen? This will be converted into an alkane, and alongside that, HCl will be released. So that's the reaction. Now, Word's reaction. Word's reaction. Now, what is Word's reaction? Remember, this is a very, 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 very important reaction. Why? The reason is this is one of the few reactions by which we can make a carbon-carbon bond. Okay. So in organic chemistry, these reactions are very important, which can give us or which can develop a carbon-carbon bond, new carbon-carbon bond. So what we do in Word's reaction, CH3, Cl, for example, methyl chloride.
আচ্ছা স্যার,
বলো।
স্যার এটার উচ্চারণটা কি হবে?
Words
ওয়ার্ডস।
reaction.
আচ্ছা আচ্ছা,
Yes. Okay.
হ্যাঁ স্যার।
Okay. Words reaction. So methyl chloride, and here 2 moles of sodium, 2Na. So what will happen? These two chlorine groups along with sodium, 2Na, will be converted into 2NaCl. Okay, and the remaining things will be connected, like these two CH3 groups will be connected. Okay, alongside that we have 2NaCl. Okay, understood? This is called Word's reaction. So what we had, we simply had a methyl chloride, but now we have ethane. So this is the way by which you can prepare ethane. Understood?
Yes, sir.
So let me give you a question. The question is quite simple. It says that how can you prepare the following alkane by using a suitable alkyl halide. See, CH3, CH3, CH, CH3, CH3. Yes, complete this with a suitable alkyl halide. Just complete this. You have 2 minutes. If you are unable to do, quickly tell me that I am unable to do.
Sir, C6H14 plus HCl.
C6H14. Why H14? Why have you taken H14?
ওই যে স্যার অ্যালকিল হ্যালাইডস এর H2 টা অ্যাড করলাম ওখানে।
Alkyl halide. Okay. So what alkyl halide are used in the last reaction? Have you written
Cl
it?
মানে ক্লোরিন। হ্যাঁ হ্যাঁ।
না না, alkyl halide. Tell me the entire alkyl halide. কোনটা লিখেছি?
মানে আগেরটা ইকুয়েশনে।
হ্যাঁ, আগেরটা ইকুয়েশন।
ও মিথাইল ক্লোরাইড।
মিথাইল ক্লোরাইড। তাহলে তুমি কি করে C6H14 বলছো?
ও দাঁড়াও ওটা দেখে নিই।
क्षितिज इसको किए?
कर रहा हूँ सर।
करो।
ও স্যার এটা 2,3 ডাইমিথাইল বিউটেন তারপরে হাইফেন দিয়ে Cl।
নো 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 নো, কেউ করেছো গ্রুপ?
নো স্যার।
নো। ওকে, দেখো, in this case, see, it's a symmetrical alkane, right? Just break the alkane from the middle like this. Okay, just break and add 2 Cl group. Like हमको दो टुकड़े मिलेंगे इस तरह के, एक ये वाला हो गया और दूसरा ये वाला हो गया, right? So with both of them just add a Cl or Br or whatever you want and add 2 sodium here. So this is the reaction. And the product is this, what you see in your screen, what is given in the question rather. Understood? দেখো আগে ভালো করে এটাকে, look at this with the pure attention and try to understand. Understood? हाँ बोलो।
तो सीएल की जगह कुछ और ऐड कर सकते हैं?
अब वही तो मैंने बोला, ब्रोमीन ऐड कर सकते हो, आयोडीन ऐड कर सकते हो।
ठीक है सर।
ওকে, हो गया? সবাই বুঝতে পেরেছো? वो NaCl जो मैंने दिखाया यहाँ पे अभी, ये दिखा भी सकते हैं, नहीं भी दिखा सकते हैं। ओके, that is not very important. What is important? The major product जो alkane हमको प्रिपेयर करने बोला है, वो alkane mainly हमको दिखाना है यहाँ पे। ओके, अंडरस्टूड?
ও এরকম করে।
এরকম করে।
ও বুঝছি বুঝছি। ও আমি কোশ্চেনটা বুঝি নাই, আমি বলছি এটা মনে একটা।
ওকে, এখন বুঝেছো?
হ্যাঁ বুঝছিলাম।
ওকে, কারোর কোনো প্রবলেম? এনিওয়ান ইজ হ্যাভিং এনি প্রবলেম?
বুঝেছি স্যার।
এনিওয়ান, কারোর কোনো প্রবলেম?
না স্যার।
দেখো সাগ্নিক,
হ্যাঁ স্যার, বুঝেছি।
বুঝছো?
হুম।
ওকে, so let's proceed. So this we have prepared from alkyl halides. So next number is from carboxylic acids. From carboxylic acids. So how can we prepare alkane from carboxylic acid? So this can be simply done by using a reaction called decarboxylation reaction. So what is decarboxylation? CH3, C double bond O, single bond OH. This is called which acid? Yes, the name ethanoic acid.
Noic acid.
Ethanoic acid. Why ethanoic acid? Because there are two carbons in
Carboxylic.
this carboxylic acid. So that's why ethanoic acid. Okay. If you treat this ethanoic acid with sodium hydroxide, that is with a base, so what is expected? The salt formation is expected. So this is the salt formation. The name of the salt is sodium ethanoate. Sodium ethanoate. Okay. Now, if you treat this sodium ethanoate with soda lime, the mixture of sodium hydroxide and calcium oxide is called soda lime. So if you treat this carboxylate, sodium carboxylate, this is basically ethanoate, but it can be methanoate or anything else. So what will happen? Carbon dioxide will be removed. So carbon dioxide will be removed. Basically, sodium carbonate will be removed. Okay. And alongside that, we'll get an alkane. In this case, it will be a one carbon containing alkane, that is methane. Okay. So this CH3, the alkyl group, will give us this alkane. So this is methane. So you need minimum ethanoic acid. Okay, methanoic acid basically cannot be used because to have methane, we need at least a two carbon containing carboxylic acid, which is ethanoic acid. Understood, everyone?
Sir.
So the general reaction is something like this: RCOONA, sodium carboxylate. You just treat this with soda lime, that is a mixture of calcium oxide and sodium hydroxide. You will get RH, that is the alkane, and alongside that Na2CO3 will be formed. Here also I have to write Na2CO3, okay, or sodium carbonate, which will be formed. Understood, everyone? Any doubt? Any query? Any doubt?
No, sir.
Nobody is having any doubt? No one?
No, sir.
Shall I move to the next one?
স্যার
বলো বলো।
স্যার এটা এটা একটু বুঝিয়ে দাও না আরেকবার।
হ্যাঁ, কোন জায়গায় বুঝতে অসুবিধা হচ্ছে বলো।
না এটা বলতে যে উপরের যেটা আর কি, এটা একটু বুঝিয়ে দাও।
ইথানোইক অ্যাসিড
হ্যাঁ হ্যাঁ
সেম তো, এখানে আর আছে, ওখানে CH3 আছে,
আচ্ছা
বাকি তো সেম। দেখো আর এর সঙ্গে আমি একটা H অ্যাড করে দিয়েছি, ওকে। সিমিলারলি ওখানেও CH3 এর সঙ্গে একটা H অ্যাড হয়েছে, দ্যাট মিন্স CH4।
আচ্ছা হ্যাঁ
সেম, this is the general reaction. RCOONA, just treat this with calcium oxide and sodium hydroxide, that is soda lime. So you will get RH, and alongside that Na2CO3 will be formed as a side product. Side product হিসেবে Na2CO3 তৈরি হবে, but side product we are not that much of concerned with the side product. Side product নিয়ে আমাদের অতটা মাথা ব্যথা নেই, যেটা main product that we need to understand. Okay.
হ্যাঁ হ্যাঁ স্যার
The next is coal-based electrolytic method or coal-based electrolysis. Coal-based electrolytic method. Okay, what is this method? Let's have a discussion. See, here also we take a sodium salt of carboxylic acid or a potassium salt of carboxylic acid, exactly like the previous one. Okay, and what we do? We just do the electrolysis of that acid. Again, the electrolysis of that acid. So as a result of this electrolysis, we get an alkane. Okay, so what is the general reaction? No need to read the mechanism, just read the general reaction. This is the sodium salt of carboxylic acid. Okay, we just take 2 moles of sodium salt of carboxylic acid. The name is sodium acetate or sodium ethanoate. Let me write down the name. Sodium ethanoate. Okay, it comes from ethanoic acid, so that's why sodium ethanoate. Just add 2 moles of water and pass electricity, or just do the electrolysis of this sodium ethanoate. So what will happen? These two CH3 groups will be attached, like CH3 bond CH3. So that means ethane will be formed. Understood? Ethane will be formed, and alongside that, carbon dioxide, hydrogen, and sodium hydroxide will be formed. Okay, if you do the balancing of the reaction, so it will be 2 NaOH, alongside that it will be 2 CO2. This is basically the reaction. So what do you have to remember? We are getting sodium, we are using sodium ethanoate, and we are doing simple electrolysis. So what is happening? The two CH3 groups of sodium ethanoates gets connected with each other and they give us alkane. That's it. Understood?
Yes, sir.
So these are the ways by which we can prepare alkane. Okay, many processes we have seen. Now, physical properties of alkane. Physical properties of alkane. Now, what are the physical properties of alkane? One by one, we will discuss. Okay. So, like the other organic compounds, okay, the smaller alkane.
স্যার
Bolo.
স্যার ওই যে তুমি একটা জিনিস করেছিলে না, ওই যে কি বলে, ওই যে একটা অ্যাট অ্যাট ক্যাথোড অ্যাট অ্যানোড এরকম একটা করিয়েছিল, ওগুলো কি গো?
ক্যাথোড অ্যানোড ওটা লাগবে
হ্যাঁ
না, এটারই বেসিক্যালি এটারই মেকানিজমটা যদি আমি দেখি। ওকে, electrolysis means there are two electrode. Okay, one electrode is connected to the positive end of the battery and another electrode is connected to the negative end of the battery. Okay,
আচ্ছা
the electrode which is connected to the positive end of the battery, quite obviously the negatively charged ions will come towards the electrode. That means it is what? Anode, right? And the electrode which is connected to the negative charge of the battery is basically the cathode. So at anode, what happens? Methyl radicals are formed, and after that these methyl radicals gets converted into ethane. Okay, by combination of two methyl radicals we get ethane, and that reaction happens in anode. Similarly at cathode, what happens? Hydrogen gas is generated. This hydrogen
আচ্ছা
gas that you see is generated in the cathode. Okay,
হ্যাঁ
which is basically not needed, so that's why I'm not discussing the mechanism of this reaction. Okay, not that much of important. What is happening, that is more important. Okay, যদি
Okay, sir.
প্রয়োজন হতো আমি নিশ্চয়ই ওটা ডিসকাস করতাম। যদি তোমাদের মনে হয় যে ডিসকাশনের দরকার আছে বলবে, আমি ডিসকাস করে দেবো at the end of this chapter. Okay.
Okay, sir.
Now the physical properties of alkane. So this is a very important topic. Okay. First of all, they are non-polar. They are non-polar. Secondly, the lower alkanes, like from C1 to C4, okay, they are gases. Okay, a little bit intermediate alkanes like C5 to C17, they are what? They are basically
Liquid.
liquid. Okay, and after that, like C18 onwards, okay, the hydrocarbons, rather the alkanes, are solids. So it is quite obvious, if you increase the number of carbons in case of alkane, so they become from gas to liquid, from liquid to solid. So this is how the change happens. Okay, understood? And a very important point is there, that is, with increase in number of carbon atoms, the melting point, boiling point increases. Melting point, boiling point increases if you increase the number of carbon atoms. Okay, so obviously the melting point, boiling point will increase. Understood? Understood? Similarly,
Yes, sir.
with increase in branching, the boiling point decreases. If you increase the branching, the boiling point decreases. Okay, understood?
Yes, sir.
Because with increase in the branching, okay, what branch chains, what happens? The molecule gets the shape like a sphere. As a result, the area of contact becomes small. So that's why the weak intermolecular force acts. So as a result, the boiling point decreases. Okay, as a result, the boiling point decreases. Another point is there, I must write it. They are not that reactive. The alkanes are less reactive. So they are called paraffins. Paraffins. Okay, we also call them paraffins. The reason is they are not that reactive. Understood, everyone? So we
Yes,
will
sir.
discuss the last topic of today now, that is the chemical properties of alkanes. The chemical properties, obviously we cannot discuss all the chemical properties today, but at least one chemical property we can discuss. The number one, that is halogenation. Halogenation. Now what is halogenation? Halogenation is basically the addition of halogen. What? The addition of halogen. So can you tell me what is halogen?
Sir, iodine, bromine, chlorine.
That means
Group 17 in the periodic
group
table.
17 elements of the periodic table are called halogen. Very good. So what happens? if you have an alkane, you add any halogen, for example chlorine, okay, in presence of sunlight. H nu is basically sunlight. So what happens, one by one, the hydrogens of the hydrocarbon, that is alkane, will be replaced by the halogen atom. Okay, one by one I will replace CH2Cl2, add a Cl2 and H nu will become CHCl3, that is chloroform, alongside that HCl. Similarly, CHCl3 and Cl2, you will get CCl4 and alongside that HCl. Okay, so this is the reaction. So we started from methane and now we have carbon tetrachloride. So all the hydrogens gradually have been replaced by the chlorine atom.
স্যার এটা
Understood?
অ্যাডিশন রিঅ্যাকশন না?
This is basically a substitution reaction. How can it be an addition reaction? Chlorine is replacing hydrogen.
ও
So this is substitution
Substitution.
reaction. Okay. Substitution reaction. Understood everyone? Any doubt? Any doubt?
আচ্ছা এই যে এইচ নিউটা এখানে কেন?
H nu means sunlight.
ও হ্যাঁ,
Sunlight is represented as H nu.
রেডিয়েশন স্যার,
হ্যাঁ বলো।
রেডিয়েশন না এইচ মিউটা?
H nu stands for sunlight. Okay. H nu stands for sunlight. The reactivity rate of the halogens are fluorine greater than chlorine, greater than bromine, and greater than iodine. Okay. So this is the rate. The fluorine reacts fastest, followed by chlorine, bromine, and iodine. Understood? Understood? Okay. So this is how it works. Okay. So how the iodination is done, that we will discuss in the next class. Okay. We'll continue further from that and we'll discuss the other chemical properties of the alkanes as well. Okay. There are a few chemical properties of alkanes. Obviously, we will discuss them in the next day's class. Okay. As of now, any doubt?
নো স্যার।
ওকে, কে বেরোলো এখান থেকে? কেউ বেরিয়েছে?
ধ্রুব। হ্যাঁ ধ্রুব
বেরিয়েছে। কখন বেরিয়েছে? অনেকক্ষণ?
এখন না, এখনই বেরোলো।
ও আচ্ছা আচ্ছা আচ্ছা, ঠিক আছে। তাহলে আজকে এত অবধি থাকলো। নেক্সট আমরা আবার ফ্রাইডেতে পড়বো, ঠিক আছে? ফ্রাইডে মেবি এই চ্যাপ্টারটা অনেকটা শেষ হয়ে যাবে। তাহলে ঠিক আছে, রাখছি আমি। আর পিডিএফটা হোয়াটসঅ্যাপে আমি সেন্ড করে দিচ্ছি, হ্যাঁ, একটু পরে।
ঠিক আছে।
ওকে, চলো।
Thank you, sir.
থ্যাংক ইউ এভরিওয়ান।
Thank you, sir.
থ্যাংক ইউ স্যার।